Assalamualaikum dan apa khabar semua? Selamat datang ke channel saya, Cikgu Hasnita. Hello again, welcome back to my physics class, and today we are going to talk about transformer. What do you know about transformer? How does transformer work? And what is transformer used for? So let's find the answer in this lesson. But before we begin, you may sit down and relax, get yourself comfortable, and enjoy the lesson. Alright, so let's begin with observing these pictures. You are given 4 pictures for you to identify which picture represents a transformer. Can you tell me the name of the first device? Yes, this is what we call as a generator. How about the second one? This is a solenoid. Good. And the third one? This is a motor. Yes. So transformer will be the 4th picture. Very good. Are you curious to find out what's inside the transformer? So to know the answer, let's zoom at this picture. It shows a simple electrical transformer. Transformer consists of 3 major parts. First, it has a primary coil, and this coil is connected to the input voltage source. Second, the secondary coil, where the coil is connected to the output circuit. And third, this primary and secondary coil are linked through layers of soft iron sheet called the laminated core. And these laminated core are insulated by varnish or glue. And these pictures show the structure of a transformer. Transformer is an electrical device which consists of 2 circuits linked by electromagnetic induction through a soft iron core and 2 coils, which are the primary and the secondary coil. So this is the primary coil. It consists of NP turns and connected to the input voltage source labeled as VP. The current that flows through the primary coil is labeled as IP. While this is the secondary coil. It is a coil consists of NS turns and connected to the secondary circuit or the output circuit. The voltage across the secondary coil is Vs, while the current flowing through the secondary coil is labeled as Is. And this is what we call as the soft iron core. So what is this soft iron core used for? It is act as a bridge to provide a magnetic field linkage between the primary coil and the secondary coil. And this diagram on the right shows to us the symbol of a transformer. Okay, we have discovered the structure of a transformer. So now let's take a look at how this transformer operates. Have you ever seen this? You may find this transformer nearby your residential area, and also you can find them along the railway and power lines. So what are the functions of this transformer? Look at these 4 choices of answer. Which one do you think is the best or the correct function? Is it number 1 or number 2 or number 3 or the last one? Yes, transformer is a device which is used to change the magnitude of an AC voltage. Now let us conduct a simple study to observe that the transformer only will work with AC voltage. So at this side, the input circuit is connected to 2 types of sources. First, we have AC voltage, and second, we have DC voltage. While on this side, the output circuit is connected to a CRO and a light bulb. And the primary coil and the secondary coil has the same number of turns of coil. So first, we connect AC voltage. So you can see that there is a current flow in the primary coil and there is a magnetic field line on the soft iron core. and at this side, current flow at the secondary coil light up the bulb. So now what happens if we increase the magnitude of the voltage? So more current will flow to the primary coil and more magnetic field line shows on the soft iron core. More current produced at the secondary circuit, causing the bulb light up brighter. And on the CRO screen, you can see there is a trace appear now. It shows that thermionic emission occur at the electron gun, which emit cathode ray. So now we try to increase the magnitude some more. So you will see there will be more current flow at the primary coil and more number of magnetic field, and again bigger current flows through the secondary coil, causing the bulb is now light up at the brightest. And what happened at the traces? The traces now shows a higher amplitude. It shows that higher current flow at the output. And now let's find out what happened when we connect a DC voltage to the input circuit. So you can see there is a current flow in the primary coil and the current flow in one direction, and this shows how the magnetic field line in the soft iron core. At this side there is no current flow at the output, so the bulb will be light off. So let's try to increase the magnitude of the DC voltage. So you can see more current will flow through the primary coil, and again this is how the magnetic field line appear. But there is still no current flow at the output, and the light bulb remains switched off. And even you try to increase the magnitude of the DC voltage to the highest value, there is still no current flow at the output. So why is this happen? Let's find out what happened in the previous study. When we connect the input circuit to an alternating voltage, an alternating current will flow in the primary coil, producing an alternating magnetic field. And later, the magnetic field line produced by the primary coil are trapped inside the soft iron core. And the changes of the current will cause us changes in the magnetic field line. And the changes of the magnetic field line on this side will cause the secondary coil to cut this magnetic field line. Hence, an induced voltage or induced current flow at the secondary coil, which light up the bulb. But what happens when we connect a DC sources to the input circuit? There will be no output voltage. Why? This is because a DC voltage where the current flow in one direction will produce a static magnetic field in the soft iron core. So this static magnetic field, it doesn't link the primary coil to the secondary coil. Hence, we can say there will be no current induced in the output circuit. And as the result, the bulb does not light up. And now we have come to the final part of this discussion to know what type of transformer that we have. Before we take a look at what type of transformer that we have, let's take a look at this example first. Suppose that the number of turns in a secondary coil of a transformer is higher than the number of turns in the primary coil, where we can write NS is greater than NP. So what do you think will happen to the output voltage? Is the output voltage going to be lower, higher, or equal to the input voltage? Well, to know the answer, let us go back to this diagram. It shows that this is an ideal transformer. What is an ideal transformer? An ideal transformer is a transformer which is 100% efficient. It means that the transformer has no power loss during operation, where the input power is equal to the output power. The input power is given by the ratio of the voltage to the number of turns in the primary coil, while the output power can be represented by the ratio of the secondary voltage to the number of turns in the secondary coil. So what happens when the number of turns of the secondary coil increases? It means that the secondary voltage will be increases. So the answer is the second choice. In this experiment, we are going to observe how by changing the number of turns of the primary coil and the secondary coil will cause a change in the output voltage. In ideal transformer, the ratio of the Vp to Np equal to the ratio of Vs to Ns. So first, let's place 2 turns in the secondary coil. So you can see that the output voltage reduced to 12. So this is how we count the output voltage. In the primary coil, we have Vp 240 volt, divide by Np, which is 40, and then multiply by Ns, which is 2. So the output voltage Vs will be 12 volt. Okay, now we change the secondary coil into 10 turns. Okay, you can see the output voltage now is reduced to 60 volt. So how can we get 60 volt? Again, Vp 240 divide by Np 40 multiply by Ns, which is 10. So it will give you an output voltage of 60 volt. Okay, next we change the number of turns into 20 and it shows the output voltage 120 volt. Again, input voltage Vp 240 divide by number of turns in the primary coil, which is 40, multiply by Ns, which is 20. So you will get a Vs of 120 volt. So when the output voltage has lowered down, we say that this is a type of step-down transformer. Okay, now let's do the changes on the number of turns in the primary circuit. Okay, so we place back 40 turns here, so it will back to equal 240 input, 240 output. Okay, so now we place 2 turns in the primary coil by maintaining the input voltage at 240 volt. So now the output voltage increased up to 4,800 volt. And again, how to determine this? So the input voltage 240 volt divide by 2, this is Np, multiply by 40, this is Ns. So the output voltage Vs is 4,800 volt. Okay, now we place 10 turns in the primary coil by maintaining the input at 240 volt. So how can we get this value? Again, Vp 240 divide by Np, which is 10, multiply by Ns 40. So Vs will be 960 volt. Okay, and last but not least, now we place 20 turns in the primary circuit. So the output voltage will be 480 volt. Okay, so where Vp is 240, Np is 20, multiply by Ns 40. So Vs is 480 volt. So this is what we call as a step-up transformer, where the output voltage has been increased. So to conclude step-up and step-down transformer, let's take this simple setup which represent both. Okay, for step-up transformer, the input voltage is lower than the output voltage. So this is the light bulb connected to the primary circuit, while this is the bulb connected to the secondary circuit. As the output voltage is greater, so you can see the bulb light up brighter. So what is a step-up transformer? It is a transformer which converts an input voltage to a higher output voltage. While for step-down transformer, this part again connect to the primary circuit, while this one connect to the secondary circuit. And since the output voltage is lower, you can see that the light bulb connected to the output circuit is dimmer. So what is a step-down transformer? It is a transformer which converts an input voltage to a lower output voltage. Alright student, remember for an ideal transformer where there is no power loss during the operation, it obeys these properties where Vp divided by Vs equal to Np divided by Ns, in which it can also be written as Vp divided by Np equal Vs divided by Ns. So I guess that's all for today. And as usual, before we end this session, let us do the checking, the knowledge which you should achieve after following my lesson. A transformer consists of a primary input coil with Np turns and a secondary output coil with Ns turns. Both coils are linked magnetically by a soft iron core. An alternating current creates an alternating magnetic field in the core which links the two circuits. The alternating magnetic field in the secondary coil induces a current in the secondary circuit. A direct current voltage will not induce a current as there is no changing magnetic field in the secondary coil. For an ideal transformer, the ratio of the number of turns in the primary and secondary coil determines the ratio of the input and the output voltage, in which Vp divided by Vs equal to Np divided by Ns. A step-up transformer converts lower AC voltage to a higher AC voltage, where Ns is greater than Np and Vs greater than Vp. While for step-down transformer, it converts high AC voltage to a lower AC voltage, where Ns less than Np and Vs less than Vp. So see you again in the next lesson. Till then, Assalamualaikum and thank you for watching. Bye!